Okay, this problem we want to find, we want to use node voltage analysis to find the node voltages, and then from this find the power supplied by the voltage source, the 12 voltage source. Now, in order to do this, we must find the voltages at the respective nodes. So we write the relationships between node A, which is declared as a node which connects two or more devices. Node A connects 6 ohm resistor and a 4 ohm resistor and a 12 volt voltage source. Node B, which also connects 3 devices, 4 ohms, 3 ohms, and a 2 amp current source. Now node C connects 6 ohms, 2 ohms, and 3 ohm resistors. Now we declare our reference nodes arbitrarily. It's right here. Now to use this, we'll find the voltages at each node. Let's say that at node A, we see that node A has 12 volts as a rise. So by inspection, node A is 12 volts. 12 volts. Now that's easy. Now find the relationship, find the node voltage at node B. Node B and node C. Now node B, we have to use Kirchhoff's current law. Let's take VB, node voltage, VB minus VA over 4 ohms. 4 ohms. See, now, find using Kirchhoff's current law, Kirchhoff's KCL, oops, delete that, KCL. That's the current going out of node B plus VB minus VC over 3. Now that's the current going out from node B to node C. Now those are currents out, but we have a current in from the current source. So these two equal 2 amps. We have VB minus VA over 4 ohms plus VB minus VC over 3 ohms equal to 2 amps as the current Kirchhoff's current law says that current in is equal to the current out. Now we write our next node voltage, a voltage at node C. Should find the relationship as, just erase this. Now we're looking at node C. Node C, the current going out of node C, one current going out there, which is VC minus VA Okay, let me make this nicer. VA over 6 ohms, which is this current. VC minus VA over 6 ohms. Now we have another current. Now, current going out. This current, VC, so plus VC minus VB over the resistance 3 ohms, and our current going out this way. So VC, so plus VC minus, well, that's ground. So ground is 0. So it's essentially VC over the resistance 2 ohms is equal to 0. Now we want to place all the currents going in on one side and all the currents going out on the other. That's why we have 0. That's why we have 2 amps here because it's going into the node, and 0 amps here because no currents are going in. Now we solve this relationship. You use a calculator. Here I'm going to substitute. We know that node A is 12 volts already, so we can substitute 12 volts for VA, and we'll have 2 equations and 2 unknowns. So let's solve this. So for node B, let's substitute 12 volts to VA. So VB minus VA over 4 plus VB minus VC over 3 equals to 2. 2 amps. Oh, my bad. So we substitute VA into here, which is 12. 12 volts. Now let's multiply each side by 12. By 12. So we'll get rid of this 4, so it'll be 3 VB minus 36 plus 4 VB, 12 here. 12 divided by 3 is 4. 4 VB minus 4 BC equals 12 times 2, 24. Now we'll simplify this. So let's simplify this. So 3 VB plus 4 VB is 7 VB minus 4C, 4 BC. So that's out. Minus 36 equals 24. Now, right here. 7 VB minus 7 BC equals 36 plus 24, 5, 60. 60. Okay, now for node C, I'll simplify this. Node C, probably gonna run out. We're gonna run out of room, but okay. So let's multiply each side by both sides by 6. So we have BC minus VA plus, well, 6 divided by 3 is 2. 2 VC, 2 VC minus 2 VB. 6 divided by 2 is 3, so plus 3 VC. VC 3 BC, 3 BC equals 0, 0, 0. Now 2 VC, so that's 3. No, so okay, 3, 6 VC. 6 VC minus VA minus 2 VB equals 0. Now we substitute, now remember that VA is 12 volts by inspection. So replace this by 12. And 6 VC minus 2 VB equals 12. So here's equation 2. Okay, equation 2 and equation 3. Equation 2 unknowns. Solve that. So VB 12 volts and VC is 6 volts once we solve this equation. 6 volts after solving this equation. So finally, we know that. So what we're saying is that at node A, so node A, which is right here, that's 12 volts. At node B, which we solved, which is VB, 12 volts. And node C, 6 volts. Node C, 6 volts. So now, using node voltage analysis, we know the voltages at each node, at each of the 3 nodes. Now we could find power supplied by the voltage source right here. By finding the current, well, we know that the current going out from VA minus VC divided by 6, VA minus VC over 6 is equal to, which is this current, and this current going into VA equals the current going out. So VA, let's try this. And then VA minus VB plus VA minus VB over 4 ohms is equal to this current going into VA, which is we'll say the current through the 12 volts, through the 12 volt, so through the 12 voltage source. Now, since we solve for VA, we plug in 12 into here, plug in 12, we plug in 6 for here, 12 to here, and 12 to here. Eventually this will be 0. So we're left with 12 minus 6, 6 over 6 is 1 amp. So 1 amp is equal to the current going through the 12 voltage source. 12 volt voltage source. Now power in this relationship is power is equal to our formula. I don't know if we have it. Go back. Power equals V times I. Power equals V times I. Now, so we have the voltage source, 12 volts, times 1 amp, which equals 12 watts. There we go.